So let's take a look at some of the other things that we can see in our solar system, some of the more fun objects. One is asteroids. So asteroids are rocky objects that do revolve around the sun. You can see there are many of them, and they all have their own orbit around the sun. Now they are relatively small in comparison to, say, a planet, but they can be very large. For example, like I said the other day in class, I'm a paleontologist, so I study dinosaurs. And very specifically, I study what happened at the end of the Cretaceous. So many of you know that there is a very large asteroid that hit Earth, right, causing a huge mass extinction event. Now that asteroid was 10 miles wide when it hit the Earth. So relatively, that is a small object. However, right, in comparison to our human scale, that's a pretty big object. Now, they don't really contribute to the overall mass of the solar system. What we tend to see is that these asteroids are leftovers. So as our solar system was forming, most of the material, right, formed the sun, and then the planets that outlie it. The leftover bits that never helped form a planet are mostly these asteroids. So this is kind of leftover from the beginning of the solar system. Most of our asteroids are found in the asteroid belt, which is between Mars and Jupiter. So as you can see, there's actually a really large space here in between these two planets. And that's where we find most of our asteroids is located in between this orbit. So like I said, there are two ideas about the origins of asteroids. Like I said, most of the time what we see is this is material that never agglutinated to actually form a planet. However, we can see that sometimes when, say, an asteroid hits a planet, or in some cases, not in our solar system, if two planets collide, you're going to get bits and pieces of that planet that are going to break off. And those can form asteroids as well, right? Relatively, kind of large pieces of rock, right, that are going to now rotate around that star. However, like I said, most of the time, I'm going to say 9 times out of 10, this is just leftover material from the beginning of the solar system. So here are some pictures of some asteroids. They look like giant rocks. The thing that's kind of hard to tell about asteroids is how big they are. There's no scale on any of these pictures. There's craters, as you can see, but there's no scale. There's no trees or anything like that. These asteroids in this picture are large. These are all over a mile wide. Right? So these are some very big asteroids. Now we can also see comets that also revolve around the sun. Most of the comets we find originate in the Oort cloud, which, if you remember, is the far outer edge of our solar system, right? So very, very far away. So they do rotate around the sun, but they stay pretty far out, and they usually have a highly elliptical orbit, right? As you can see, where they spend most of their life cycle far away from the sun, but they do come close to the sun at some point. We also see some originating in the Kuiper belt, which is much, much closer to the sun itself. Now, of course, as that comet gets closer to the sun, we can start to see the tail, right, that forms. So a comet, right, is basically just this. Well, we're learning more about comets, actually, because hopefully you recognize last year we landed on a comet, actually. So we're learning more and more about it. But the comets are solid when they're far away from the sun. As they get closer and closer to the sun, they quite literally start to vaporize. They start to melt. So as the sun's rays are hitting the comet, right, it's going to melt, and that tail is always going to point away from the sun. So you can see as this comet goes around its orbit, its tail is always pointing away from the sun. So like I said, a comet is basically a fuzzy object in the sky. Here's a great picture of the Hale-Bopp comet, what they look like. They're mostly composed of water vapor and carbon dioxide, so things that aren't obscure at all. We do actually find some organic compounds in the comets, which is really pretty neat in my book. We actually find amino acids in some of these comets, which if you take me next semester for historical geology, we're going to definitely discuss that because this is most likely where life originated. But the comet itself consists of a head, right, which is really small. That's the front part there. This is where most of the comet's mass is. Now, like I said, we've always assumed that it's ice and dust. However, because we landed on a comet last year, we're learning a little bit more about it, so that's pretty cool. And of course, the comets have the tail, which, again, remember, the tail always points away from the sun. And then, of course, we have meteors, right, meteorites, which are much smaller objects. Most of the time, meteors are broken up pieces of asteroids, right, so they're much smaller. So once one of these rocks hits Earth's atmosphere, we can physically see it, and that's what we tend to call a shooting star. So if you've ever heard of that term before, that's what it's referring to. It's not an actual star, it's a meteor. And as it hits the atmosphere, it's traveling very, very fast, tens of thousands of miles an hour, and it starts to hit the friction of our atmosphere, and that friction starts to cause it to burn up. So that's what you see is that bright streak. Okay, we call that a meteor. Before it hits the atmosphere, we call it a meteoroid, right? So it's undisturbed. And once it hits the ground, we call it a meteorite. Now, most of the time, meteorites are pretty hard to find. If you really want to find some, your best bet is to go to Antarctica. They stick out really, really well on all that snow.